Hi, welcome back with Mr. Can of Maths, and we're doing reverse bearings today. So this is where we talk about processes where you go A from B, and then they ask you to go B from A. So you would think that you just switch around the numbers, but it's not actually that easy. What we're going to actually have to do is draw a diagram, always with two north lines, and then use one of our angle theorems. A lot of people like using the alternate angle theorem, where angles when you have two parallel lines. So our parallel lines, when we are doing bearings, these will be our north lines, right? And then we have a bisecting angle through them, right? So their alternate angles are equal. Co-interior is one that I often like because it enables us just to sum together the inside angles to get 180. And then corresponding, you might use it kind of less, but you'll still end up using it. So all of these things or theorems we'll use with north being our parallel lines or our pair of parallel lines. So here we have example 1. The bearing of B from A is 130. Find the bearing of A from B. So we know it's a reverse bearing. So draw a diagram showing what we know in the question. Okay, so this is just a rudimentary sketch. So here I'm drawing up a line, and I know here I'm going A to B. Okay, on the way back I'm going B to A. Okay, so that means right away I can tell you that, hey, this first little thing I've written is A right here. I know it's 130, and if 130 is somewhere down here, so here we're just going to call this 130 degrees, and we'll call this B, right? So that's basically what the first period of first full stop, whatever you want to call it, tells us. So now we want to find the bearing of A from B. So what do we have to do? Look at step 2, draw the other north line. So that means here, and sorry, I should have labeled that north line. Always label your north line. Now we want to draw another north line, this time at our other endpoint. So, and label this one north. Because what does it always say we have to do to measure? Well, we always measure from north. So if we're going B and we want to go to A, we really want this angle, right? In blue. So how exactly are we going to find out that? Well, this is where I said you can choose any of the theorems, and it just depends on the situation or what you might want to do. So I personally think that for this one, because that's the reflex angle we want, I just want that angle. Because I know that 130 degrees plus this angle I'm going to call theta equals 180. Right? So therefore, we can see that theta equals 50. And then our bearing, we can say A from B is just equal to, well, we just have to take away 50 off 360. So here, that's 360 minus our theta, which equals 310 degrees. And we substitute that into there. Similarly, you could do this. And I'm just going to erase this for a sec. Just this little part right here. I'll leave everything else. But here, if we continued our line down, well, we know that this is also 130 degrees. Right? And we know that over to here is 180. And we can add those together. We'd get 310. We could find that that's 130 in green. And we can find the theta going 180 that way. So there's lots of different ways. It doesn't really matter which way we choose. So example 2. So first thing we want to do is let's draw a bearing line for our north. And then, sorry, just trying to get rid of some of this stuff on the page. Don't know where it's coming from. Want to draw our north line. We're labeling this A, and we're 315, which is somewhere up there, right? And so we want to draw another north line. Okay, so if you want to do a little sketch the first time, I always suggest drawing it with a ruler. And I'm actually going to redo that because I want to be able to see best as possible, maybe a theorem, or which theorem might be easier. Okay. So, right. We got our two north lines. Label them north, north. A lot of this, if you draw the diagram, life will be a lot easier when you go to solve this. So, we know this is 315, right? That is what we know going in. What we're trying to figure out after is we want to start at north and measure, and we're going back. So we want this little part here. We want this, right? I'm actually going to do it in red. So we have that. So how exactly can we figure that out? Right, so any sort you want to do. I quite enjoy doing the interior angles because finding out that, right? Because I just know every time I can work with my 360. So the 360 minus off 315, and this will be equal to theta, which is 45 degrees is equal to theta. Right? So we know that theta is that, and then to figure out what we're missing, we know 180 minus that theta will give us our bearing. This is why there's no one method here. It's just personal preference and what angle theorems you know / remember. Here, our bearing then, well, if theta is 45, our bearing has to be 180 minus 45, which is 135 degrees. So, example 3, let's draw this out. So we know we have our north line, and we know that a bearing of 40 is somewhere over there. So I'm going to draw myself another north line. Like so. Okay. So let's just quickly label everything. We know that this is A, this is B. We know that that is 40 degrees. Right. And now, what are we actually looking for? So if we know that that's that, we're looking for actually this. So, sometimes when you stretch your north line the other direction can be really helpful because we know that this part in green is 180 degrees. And we know that this is 40 degrees because that's an altered angle. So in the end, A from B is simply equal to our 40 there from alternate angles theorem plus our 180 from the idea that straight lines are 180 degrees. So we can find our final answer as 220 degrees. So now is a good time for you to pause the video, take a try at these questions. When you get stuck or whenever you're done them all, press play and then we'll go through the answers. Alright, so welcome back. First off, I'm going to draw my north lines out for all these questions. And because it doesn't matter what they actually look like for the most part, I'm just drawing two straight lines with a little gap in between. Because we know that that's how it's going to work out. And sometimes when you draw it like this, you might actually see the angles pop out a lot easier. Or what theorem you can use. So we know it's 90 degrees. So that means 90 degrees is a line over like that, right? Next one, I know that 135 degrees kind of points downward, so I'm going to put a line down like that. 235 is the opposite direction. 247 still down kind of that way. 342 is going to be up there, and 45 degrees is up there. If I went through that a little bit quick, don't worry, you'll see where it comes from as we go through. So, now we have to label, right? We know that we have an A and we have a B in each of these. And they all just go left to right based on how I drew them. If you do them differently, your labeling might be a touch different, which is fun. But with my conventions and what I've shown you, they should all match up as such. Okay, so we know A to B, or B from A is 90 degrees, right? We know that that is 90. We now are looking at B, and we want to get back to A. So we know that that is the 360 minus 90. So we are going to get that answer. I'm just going to change so you can see the answers in better. So the answers I'm going to do in red, and that's going to be 270 degrees. Next, this is your 135. So we're looking for here. And so we can notice, well, what can we do? We can find out that co-interior is that. So we can figure out, or we can find that that's 135 and 180. A whole bunch of different ways exist. I like co-interior because you typically work with a smaller number. So I'm going to find that that's 45 for our co-interior. So 45 off of 360, right, is what we're doing. So take away 45, and your bearing is going to be simply 315 degrees. Next, we are doing 235 degrees. So that is actually, sorry, I got my labels backwards on that one. This one should be A, and this should be B. So A to B is 235. Now we want that little bit back. So we just have to do 235, 360 take 235, which is going to result us in 125. So here we get 125 degrees. So now we have to subtract that from 180. So we take 180, subtract that 125, and we'll find out our bearing for here is going to be 55 degrees. Moving down, so we're doing, and I really apologize for doing my labels like that so quickly earlier. We're going 247, so we're doing that again. So this is A, we're going to B, so we're doing 360. We want to minus off this 247, and this will give us this angle right here of 113. Okay, but we want this, right? So we have to do 180. Sorry, not 180 minus 113, and we'll get the result as 67 degrees, or 067, keep in mind, right? 3-digit. And actually the last one, 055. Continuing on, we know A to B is 342. So we know the angle here that's missing is 18 degrees. And so 180 less 18 is 162 degrees. And lastly, certainly not least, if this is 45 degrees, and we want to find out if that is A to B is 45 and we want B to A, we are going to have to do 180 minus off this 45. Doesn't look like a 5. Minus off this 45, we get 135 degrees. And then we have to take, so that's this 135, and then we take that off our full 360. So we take that 135 off of our full 360. We need 25, and so 225.